Hey man, where are we at?
So this is Helios Labs, as you can see on the wall.
Helios Labs. What's your name?
Alex.
Alex.
Yeah.
What do you do here?
So I'm a designer and co-founder of Helios.
Okay.
And this is my baby. I designed this modular weather station you're looking at. I know it doesn't look like a weather station. Way too sexy to call it a weather station. So we're trying to figure out what we're going to call it. But that's the basic functionality of this.
Sure.
And I'm going to go through what all it does.
Let's do that.
It's about 6 feet, 4 inches tall. It takes up about a 3-foot circular radius. And if you start at the top, this little sensor right here collects rain data. So that gives you inches of precipitation over a specific time. And then this area here will be our radiation shield, where all our atmospheric temperature, VOCs, humidity is collected with the BME 680 sensor. And then we have a PM 2.5 in here as well that collects particulate matter from the air. So anything that's in your air as small as 2.5 microns, it'll detect it, it'll give you that information. This right here is our wind speed anemometer, and we collect wind speed using the Hall effect sensor, magnets, and that sort. This is our wind vane. This gives you wind direction. All this sensing technology is being patented, so some of it I can't really talk about, but
Sure.
some of it's just standard stuff. Inside this center bulb here is all our batteries, where everything is connected.
Let's talk about that real quick.
Okay. So
That's the charger.
yes, so this solar panel has a wire coming out of it. It goes up through here with a metal shaft running through the structure, and it lands in here, charges the battery. That battery powers all the sensors. So yeah, so that's solar power. And also comms is in here. We have a Wi-Fi Wi-Fi modem that uses cellular communication to actually deliver the data to our front-end portal, where users can actually see real-time data coming through. This right here is a beautiful Savonius wind turbine, vertical axis.
Ooh, wind
And
turbines.
that collects wind energy.
Yep.
So we have a dual energized, dual purpose system that you're not only getting solar, but you're also getting wind. So,
Man after my heart.
and this bottom bulb here houses more sensors. So this area here is a light scope. We collect UV light through here, and that sensor is actually sitting inside of here. And then there's a compass that sits right here, so we can orient the station south or north, however we need to get to sunlight. And then the base is just a holder in the middle with 3 anchors coming out that gives it a pretty solid stability. So,
Sure.
yeah.
And everything is 3D printed right here in your lab, and we'll show a video of that too.
Yeah.
But we're looking to deploy these in some natural disaster style weather events here real soon, huh?
Absolutely.
And then what is this thing right here?
So this right here is a satellite communications module. This is a Globalstar. I'm not sure the actual technical name
That's
of
it.
it, but this will transmit all the data via satellite if there's no cellular coverage. So we could, there's multiple ways of skinning the cat here,
Sure.
and we think we have a pretty good handle on how to actually do this in a way that's effective, in a way that is kind of fail-proof, and yeah, so hopefully these will be a household name here soon.
Like world's greatest roofer.
Right. So
Let's
we'll
go
to the
then.
lab,
Yeah.
show you where the magic happens. So these are all our sensors right here. We have a bunch of sensors, wires, all this stuff. These are atom lights. These are the microprocessors we use to actually transmit the data from the sensor to the Wi-Fi modem or the satellite device, and then sends everything up from there. It's all Bluetooth, so it's wireless.
Okay.
These are our printers. These right here are printing glow in the dark, but
Printing
this
right
is
now.
PLA Plus printing an air cup. That's a part of the radiation shield. Most of these are air cups because we have to print a lot of those.
And then it takes about a day to make these pieces.
Right. about a day to make the pieces.
Yeah.
As you see, we have Ender 3s and Ender 5s. And then we have a resin printer with a curing station.
That's pretty cool.
Yeah, Allet resin, and that's the curing station for it. These are a bunch of parts here coming for the atmospheric nodes. These are the bigger parts that kind of get put together. But yeah, so
That's
this
neat,
is where
man.
the magic happens.
Look, we've been watching this one for about the past hour. It was pretty cool. 3D printing in general is cool, but to see it being used for a device like what you guys have,
Yeah.
that's awesome, man. Hey,
Yeah.
look forward to World's Greatest Roofer and Helios maybe working together in the near future.
Yeah, dig it.